Assalamu alaikum. Section 2, talking about the oxidation number. Actually, oxidation number has no physical meaning, but maybe it is somehow related to the charge. And what you want to know in this section are some points, and then we will move directly to application. Number one, oxidation number of an element. Okay, the element is the molecule that consists of one type of atoms. Oxidation number of element, any element, equals 0. Okay, 0 means if you have sodium, if you have, this is monoatomic molecule, it is the molecule and it consists of one atom. O2, Cl2, O3, O3, ozone. What? Okay. O3, this is 3. Okay. S8. Okay. All of these are elements, and when I ask you the oxidation number of oxygen, for example, of Cl and Cl2, and of sulfur and S8, it is 0. Number 2, in the ionic compound, the oxidation number of each species equal the charge of this species. You know that ionic compound consists of ions, positive and negative. So the oxidation number on each ion equal the charge of this ion. So let us write it. The oxidation number of each ion in ionic compound equal its charge. Example, for example, let us say NaCl. This is ionic compound. How do I know that it is ionic compound? It consists of metal and non-metal. I said before, any element, group 1 or 2 or 13, till group 13. From 1 to 13, all of these are metals. From 14 to 17, non-metal. 14 like metalloids, like carbon, they make covalent bond. 15, 16, 17 are all non-metals, and the 18 they are noble gas, so we will not deal with it. So from group 1 to group 13, they are all metals. Sodium is group 1, so it is metal, chlorine, and it has the charge of the ion is what is the group? It is group 1, and it comes first because you know cation comes first and then anion. So sodium comes first, so this is the cation, positive, and it is group 1, so it's positive 1. I said group 1, group 2, group 13, group 1, charge 1, positive 1. Group 2, charge positive 2. Group 13, charge positive 3. Group 15, negative 4, 16, negative 2, 17, negative 1. I will write them to you. So 17, so the charge is negative 1. This is the oxidation number. So sodium, the oxidation number is 1, positive 1, you can say also, and the chlorine is negative 1. Negative 1. Fine? Okay, let us take zinc sulfide, zinc sulfate, SO4. Type. Sulfate altogether, this is the anion, and it has a charge of negative 2, and the zinc has the charge of positive 2. This is the oxidation number. So what is the oxidation number of zinc? Positive 2. It comes first, so this is the cation. Okay, and the sulfate is divalent anion. We memorized this from section 1. So sulfate is altogether is negative 2. Right. I want the sulfur alone and I want the oxygen alone. Pay attention. The normal oxidation number of oxygen is negative 2. Oxygen is group 16, and the oxidation, the charge in group 16 is negative 2. Negative 2 times 4, negative 8. Type. How much I put here positive charge such that the total is negative 2? Negative 8, so here positive 6. So again, positive 6 and the negative 8 equal negative 2. So the oxidation number of sulfur in the sulfate is positive 6. And the oxygen here, the normal oxidation number for oxygen is negative 2, like this. Okay. Number 3, for covalent compound. The covalent compound, they don't have a charge. So deal it as ionic, as if it is ionic. Okay, and for example, let us take carbon dioxide. How I know that this is covalent compound or molecular compound? Because they are not two nonmetals, carbon 14, oxygen 16. The teacher said the metals are from group 1 to group 13. So these are two nonmetals, so they are molecular or covalent compound. Okay, we said that in ionic compound, cation comes first. So if we deal it as ionic, so this means that carbon comes first, this is the positive, oxygen deal it as negative. يعني the more electronegative atom, the atom to the right of the periodic table, 16 and 14. So 14 comes first and then 16. So 14, as if they are the cation, the less electronegative, because the electronegativity increases as you go right. And oxygen, the more electronegative, as if it is the anion. The normal oxidation number for oxygen is negative 2, because this is group 16. So negative 2 times 2 is negative 4. This is a compound, a molecule. If you touch it, you don't get electrified, so it is a neutral. So carbon here must be positive 4. Okay, another one, HCl. Okay, so this will be positive and this will be negative. Hydrogen is group 1, so it will be positive 1. Chlorine is group 17, so it will be negative 1, like this. Number 4, if you measure here negative 1 and positive 1, it will be 0, because the algebraic sum of the oxidation number of a compound or a molecule equals 0. Algebraic sum of a molecule equal 0. Okay, يعني N2O5 dinitrogen. Nitrogen and oxygen are nonmetals. This is a covalent compound. So when we name it, we say the first subscript and then the atom, second subscript and then the root of the atom plus I. So this will be dinitrogen pentoxide. Okay, what is the oxidation number on each atom? The normal oxidation number of the oxygen is negative 2. Type negative 2 multiply 5, so the total negative charge is negative 10. So the total positive charge must be positive 10. And we have here 2, so we multiply by positive 5. So the oxidation number of nitrogen in this compound is positive 5. While in NO2, for example, normal oxidation number of oxygen is negative 2 times 2, so it is negative 4. So the nitrogen should have oxidation number of positive 4. While NO, normal oxidation number for oxygen is negative 2, so the nitrogen must be positive 2. While in ammonia, NH3, normal oxidation number for hydrogen is positive 1, so the nitrogen here must be negative 3. Positive 1 times 3, positive 3, so nitrogen must be negative 3. While the oxidation number of nitrogen in nitrogen gas is 0, because this is an element. So you see, the nitrogen in each compound here has different oxidation number, such that the algebraic sum, the total oxidation number of any of these compounds equal 0. 5. The algebraic sum of the polyatomic ion equal the charge of this ion. Write it. Algebraic sum of polyatomic ion polyatomic ion equal charge on this ion. Okay? CrO4, chromate. Chromate has a total charge of -2. The normal oxidation number for the oxygen is -2. What is this? Okay, -2 times 4, -8. So chromium must have a charge of +6, such that the total charge is -2. Phosphate, BO4, -3. All together. So oxygen is -2. This is the normal oxidation number. -2. I don't think this is clear at all. -2. Okay, time 4. So phosphorus -2. So this must be +5, yes. So +5 plus -8 equal -3. Ammonium, NH4 plus, all plus. Type. Positive oxidation number of hydrogen, +1. So +1. So nitrogen here must be negative, yes, -3, such that -3 and the +4 equal +1. Fine, let me adjust this. +1, -3, and so on. Number 6. Exception. So either it doesn't write or it writes continuously. Exceptions. And for sure, you will have some of the exceptions in the exam. What are the exceptions? I said before that normal oxidation number for oxygen is -2. -2, except in 2 cases. Oxygen fluoride, even from the name, from the formula, oxygen fluoride. So as long as oxygen came first, so it is positive. Because, pay attention, the fluorine is the most electronegative atom in the periodic table. In all its compound, it has a charge of -1. It can never be positive. These are 2 nonmetals. This is covalent compound. So what comes first and what comes second? What behaves as cation and what behaves as anion, if we will treat them as anion? Fluorine is always oxidation number -1. So this means that here oxygen will be +2. This is exception for the oxygen because it reacted with a more electronegative atom, which is fluorine. And the second example is in peroxide. In peroxide, this is the formula, H2O2. Type. The normal oxidation number for hydrogen is +1, right? So +1 times 2, so the total positive charge is +2. So this means that the total negative charge must be -2. So this means that we have to put here -1, such that -1 times 2, -2, go with +2, and the molecule is neutral, right? So this is also an exception. So the normal oxidation number for oxygen is -2, except in oxygen fluoride it is -1. It is +2, and in peroxide it is -1. Right. The normal oxidation number for hydrogen is +1. It is group 1, so its charge is positive 1, as the teacher said before. Right? What is the exception? Except in metal hydride, like calcium hydride, sodium hydride, potassium hydride, lithium hydride, any metal under the hydrogen in the periodic table. If you go to the periodic table, see group 1, hydrogen comes first. Under it there is lithium, under it there is sodium, under it there is potassium, there is rubidium, there is cesium, like this. All these elements are more metal than hydrogen. Actually, hydrogen, yes, it is in group 1, but it is not metal. So all the elements under it are more metallic than it. So they behave as cation better than the hydrogen. So when the hydrogen reacts with a more metallic substance or a better cation, the element comes first and the hydrogen comes next. So this is why even see in the nomenclature we say metal hydride. طيب يعني we put the root of the hydrogen and then ion, يعني we treat it as an ion أصلا, right? Like مثلا sodium hydride. See, sodium comes first, so this is the positive and this is the negative. This is an exception for the hydrogen, right? Calcium hydride, CaH2, because calcium is divalent, so it has here, C, negative 2 times 1, negative 2, positive 2 times 1, calcium positive 2, negative 1 for the hydrogen multiplied by 2, negative 2, okay? It is, so hydrogen is positive 1, except in hydride it is negative 1, as you see here. This is also an exception, and that's it.